Whoa. Hello. If you're excited by the idea of watching someone mess around with an unreleased database, then you're in the right spot because that's what I'm doing today. Today, I'm taking a look at a new feature that's being released in Cassandra 5.0 that I'm really excited about. It's SAI. So SAI stands for Storage Attached Indexes. It's built on the same principles as SASI, which was released in the Cassandra 3 TikTok when we were doing TikTok releases, which I'm glad that's over. Wasn't great. The idea is that we write index data along with the SS table data. And the reason why this is so useful is because you don't have to worry about keeping the indexes in sync with the base table if the index data is immutable in addition to the SS table data. Once the SS table data is written to disk, that's it. So it makes it easy to do backups. It makes it easy to stream out to like other nodes when you bootstrap into the cluster, because you can just send that data. There's a lot of really, really good reasons to use it. There's a lot of really good design decisions in it. The original SASI work was not based on Lucene, and the new stuff is. So SAI is now using Lucene, which is interesting because it actually allows us to take advantage of a whole slew of like Lucene features. You kind of just get it for free. And also is interesting because it's Lucene has like decades of work behind it. So it's a mature library. You'll probably hear some people have like grievances with it. That's kind of one of the things that happens with an older library, but I think it's a really solid choice. From a design perspective, I think it makes a lot of sense. So what I'm going to be doing today, and I'm actually still okay. My cluster is up. What I'm doing today is taking a look at a workload that I've created for SAI with nice. What's up, Caleb? Thanks for joining, bud. Hopefully, I don't make any incorrect statements about SAI as I'm evaluating it, and maybe I'll say something halfway intelligent. So, for anyone that's not like closely following along, this person, Caleb, is one of the main folks that are working on SAI. So it's really exciting that he can fact check me in real time as I stumble through my attempt to figure out what works, what doesn't work. Just a disclaimer, when I do these working sessions, I aim to break stuff. So if I break something, it's not because SAI is terrible. It's because I want to make sure that this is the best possible version of it when it gets released. If we don't break stuff, someone will break it. Yeah, buddy. Oh man, I'm not nervous. I'm feeling great. I think this is gonna be pretty fun. So I'm just gonna bring up a screen here so you can see what I'm up to. So I've got my so I've got this working. Let's see, can I do this? Will this work? Yeah, there we go. Cool. Okay, maybe I should. Can I be smaller? Can I be smaller in my layout? There we go. Cool. Let's go with that. Cool. Smaller in my layout. So basically, what I have here is a 3-node cluster. Nothing wild here. And this is running through my EasyCast lab tooling. So I just set this up like 20 minutes ago. There's no data in here. Look at this. I didn't even set that up. Source. So if we jump on the first node, we can take a look here. We can see that, it's test cluster 5.0 beta 2. This is literally, the reason why I only started this cluster, I wanted to start it a couple hours ago and fill it with some data. Actually, I'll just start filling it with data now, because I'm gonna talk a bunch about what I'm doing here and the testing that I want to do on this. So let's just run. We're gonna run this for an hour, and we're gonna run this only with a million partitions. So I have, we can't see right now that I'm looking at is my SAI code. Let me actually pull this up. This is probably going to be interesting. Well, let me start this. Let me start the test. Let me start the test first. Getting carried away. So what are we doing here? Let's just see what this looks like. So easy cast stress, as I've mentioned a couple times in the past, this is my rebrand of TLP stress. I was really happy with the work that we did on TLP stress. I thought it was really cool. And so here is kind of the rebrand. I mean, TLP technically doesn't exist anymore, so I don't want to call it that. So we've got this table. So it's got a partition ID and a clustering column, and then a text field and an integer. I know that on my to-do list is to add more types to this. So the cool thing about this is we can actually configure this test to query like multiple fields. So I'm just going to run the default really simply. So we're going to do this. Easy cast stress, run SAI. I'm just going to say that we're going to run this for an hour, and let's do a million partitions. Why not? Actually, no, we're going to do 100,000 partitions, and I'm going to populate this with 5 million records. And one of the interesting things in here is that there can be up to 10,000 rows per partition. So I actually want to get some data. So the first thing that we're going to get out of this is what happens when we're indexing. And so I want to actually test this. I want to get an idea of what kind of throughput I can achieve with this. So I'm using one of the new parameters that I've added to Easy Cast Stress recently. It says max WLAT, max write latency. Okay, so I don't want to exceed 20 milliseconds of write latency. And I'm not going to, so I don't know how fast the reads are going to be. I have a feeling that we may, I don't know. I honestly don't know. I'm going to run a couple different tests. We're going to do some with some global queries and some over row, like limited to partition. These are going to have very different performance characteristics. So I'm going to run 2 different workloads. I'm going to start with running ones that are not global, because global is going to be brutal with a lot of SS tables, and I don't have enough data here. I'm probably going to end up setting up another test, and I'm going to run this thing with multiple gigs of data. And it may also be interesting to kind of do it across slower block devices, so we can kind of see what happens. Like if you want to run, global queries on EBS, I have a feeling that it's not going to work very well, but that's just my gut. So here we have index fields. So this by default, I should really make this. So by default, we're indexing the int and the text field. And then by default, we're going to search the text field. I think that's okay. So let's just do, let's see. By default, I think that we're setting, you know what, let's just go back here. Let's just go onto this. No, not fields. I love how I don't even know commands in my own tooling. Yeah, fields. What's the problem with fields? Whatever. I don't even know. I'm not going to worry about it. So by default, the text fields are, let's see. What are we doing? Okay, so it's sections out of a book. So it's actually going to be between 5 and 10 words out of a book. So very, very small text fields. Let's just leave it. Let's just leave it. We're gonna go with this, and then I'm gonna let this go. When it starts writing, I'm just gonna tell it to do 10,000 queries per second. This is basically a starting point. So what'll happen is there's a warm up period where it warms up to the 10,000 per second, and then it uses the feedback mechanism of whatever it's seeing for latency for the max WLAT and the max RLAT. So it will adjust the throughput. So here we have, let's see. Yeah, so let's just see how this goes when we get started. Small test. This is not meant to be crazy. I just don't have the time to do something that's totally. Oh, it would also help if I actually provided my max RLAT. I'm gonna go with 100 milliseconds. This is going to be, you know, I'm expecting that what I don't want to do is end up with like 2 queries a second or like 5 or some small number. But I have a feeling that's going to be not. Well, we're not dealing with a ton of data, so it actually might be fine. So this is definitely a small use case. There's 5 million records pre-populating. 100,000 partitions. There's plenty of use cases where you would only have 5 million records, but it not be like, usually with Cassandra, we're like thinking dozens or hundreds of terabytes or petabyte scale when you get really big. So this guy's going right now. So let's just take a look and see what is happening. So if I jump off here, so I'm just going to leave this here. This is going to be off to the side. We're going to just watch this. So this is populating. So we're at 4%. So we're just right now that we're going to take a look at performance for this particular workload. And right now, which is just the writes. So let's take a look at what happens when we're pushing writes through this thing. I'm going to do 2 things here. First off, I just want to get a sense for what's happening on the machine. So this is my, I really like HTOP for getting a high level view, but I've modified, I've set this up, which is a different default. So if we go to if you hit F2, you can actually see like some really useful information. So I've enabled tree view, and that's here. And I've enabled show custom thread names. The reason why that's awesome is because I can then go down to Java and I can see here that I can see where my CPU time is being spent. Oops. So we're just going to go ahead and sort this by percent CPU. Look at that. So this is nice. It's really handy to be able to sort by CPU because we can actually look just and see like where the overhead is at the thread level. Is this going to work? No. Why isn't that working? All right, I guess I have to rebuild the image. So just a little bit of background on this. The reason why I didn't find that image, that command. There's EasyCastLab builds a AMI with all of the Cassandra versions on it that you would care about. What's going on here? Completed. Everything's looking good here. Nothing dropped. Nothing dropped. Awesome. And latency in the queue. Huh. That's interesting. Okay, so gossip. What's going on there? That's micros. Okay. So this thing is my P. Oh, sorry, that's my max latency. So there's 6 milliseconds of latency queued up here. Not a big deal. We're fine. Okay. And then let me just double check one more time. Whoops. Okay, so we can see here the bulk of the time is spent in these mutation stages. That's exactly what we're expecting to see. We're not really seeing a lot of I/O, and that's definitely because there's just not any I/O data to report. Like there's nothing on disk right now. We do that. We can go here. Okay, so we've only flushed one one SS table, and not too big. It's interesting that this is only 42 megs. It's a little weird. It's like a really early flush. Hope I didn't. I'm just going to double check here and make sure I didn't misconfigure this. So one of the cool things about this utility is that I can do this. So this patch, these patch YAMLs are basically like fragments of the full Cassandra YAML, and it takes the original YAML and then patches it with this. And it also updates the listen address because there's no reason to have to do that manually. So that's always kind of the pain with one of the things I don't love is how the configs have to be different on every machine. But you can put in the interface, but again, that can change depending on the machine, so it's a little weird. Okay, so this guy's here again, small flushes. And if we take a look at this, I mean, there's 360 megs worth of data. So let's just go here. Cassandra data. Oops. This is just me getting this stuff set up. I know it's like not like the most exciting thing when I'm trying to figure out what I'm doing. So I'm guessing here, maybe Caleb can confirm this, that the index data probably counts towards the memtable memtable memory limit. That's just a guess. I could probably also just increase the threshold because there's no reason for it to flush this early. There's like nothing on here. Anyway, this is 66% done. Let me just, it does. Yes, nice. I love when I make a guess and I'm right. Boom, confirmation. Love it. Thanks, buddy. So let's take a look at some of the cool things that are in here now. Here we go. C-Flame. The EasyCast Lab tooling makes it incredibly easy to figure out what is actually happening on your system. If you type C-Flame Cassandra 0, it'll just go ahead and take a flame graph. So this is gonna take a minute. The cool thing is that you can pass other parameters. C-Flame, what this actually is doing is this is SSHing into the node, and there's a command on the node that's just called flame graph. And normally when you run a flame graph, and I guess I'll just let me just grab my post on flame graphs so you can, if you're curious about how these things work. I've done a few videos on them, but I really think that it's useful to know this stuff. There we go. Comment. So if you, there we go. Let's see. Can we get a ticker? Yes, there it is. Async profiler. God, that's obnoxious. I love it. The flame graph script on the node. I'll just quickly jump on there and show that. Whoops. So basically what this does is it grabs the date and it sets an automatic out file. And then when it runs it, it uses the ASProf script, automatically sudos for you, so you don't have to worry about that, because it's kind of happens every time to me. I always forget that I need to do it. Automatically sets the out file for you, and then passes along any parameters that you pass through. So you can actually call flamegraph -- reverse, and you'll get a reverse flamegraph. And then this here is just a convenience function, script that all it does is it's funny. All it does is output the process ID of Cassandra. So it just makes it so I don't have to do the whole PS, AUX, all that nonsense. So here, this is awesome. So Caleb, this is why I'm so glad you're here, because I don't have to just guess at everything. So it looks like we've got some metrics that are available. So this is awesome. So we should probably so if you're going to use SAI, you should definitely make sure that you're graphing this, because this is going to be kind of weird if you don't. Anyway, this is running. So I ran my flame graph. Here's what's cool. It connects. It runs the flame graph. Show you the code for this. So this is a bash function. What this does is it grabs the host that you pass in, so Cassandra 0, and then it automatically runs my flame graph on the remote instance, and then rsyncs using this thing, and then goes ahead and rsyncs all the nodes artifact directories. So everything is automatically output. So basically, I already know I have something in here. And then if I want to open it up, it's pretty easy to do. Let me just switch to the right screen. Boom. So here's what's awesome about this. In that one command I ran, I was able to get this, which is giving me this is just an understanding of where my CPU time is being spent when we're in this write phase. This isn't using some crazy amount of CPU. This is literally just staying within the within the parameters that I told it. So it's probably if I go here, probably going to see, look at this, in populate phase, current limiter 5400. So it shows that it shows our adjustments. So here it's 5600, 5400. So it's basically doing kind of a little sine wave type deal. Oh wait, I'm not even showing the right screen here, of course. I need to figure out how to get a dual view so I can either have two windows up and switch between them, because the way that this works right now is kind of not great. I don't love it. Anyway, this is what I was trying to show. So this is our see this right here in populate phase. Current latency 324 is over max latency 2. So clearly there's something happening here on the Cassandra side. It's almost certainly GC. it's always GC, and that's kind of the headache that they end up running into. I have this set to do a max pause time of 200 milliseconds, but you know, it might not be. Let's see what it's doing here. So if we're looking at the latest GC stuff, oh man. I love how they express this in nanoseconds now. It's just like, come on. Yeah, so the easiest thing to do here is actually make use of a either what's it called? GC Easy, which I love. I'm not yeah, it is always GC. My hopes remain high for Java 21, baby. Maybe we can get Cassandra 5.0 on Java 21, because Java 21 comes with generational ZGC, which will hopefully give us all the benefits of the concurrent collecting with benefits of generational collectors. I actually have I did a branch off trunk that made that change. Maybe I'll reevaluate it. I don't know. If people want to see that, then I could do a experimental like Cassandra 21 generational ZGC type thing. Anyway, enough of that. Let's go back to here. So our progress is almost done. So the queries that this is going to be running. Well, first let's just take a look at the schema. Okay. Okay, so here we have 2 indexes. And let's just take a little sample of the data. So this is just coming out of a book. So remember I said this was like 5 to 10 words. Okay, so now, oh, almost done. Hey, what's going on? Welcome, Harsh. Good to see you here. Thanks for hanging out. Having a nice time. Just doing some tests. So the queries that this is actually going to be running without, let's see. Did we have a command to? I know I created a JIRA for it a while ago for I wanted statistics around prepared statements about which ones of those statements were actually being executed, but I don't think we actually ended up getting that in here. Oh, greetings from the US. Thanks for joining. Oh man, and you must be up late. You're like getting ready for bed, just thinking, hey, I'm going to learn a little bit about Cassandra. I love it. Or it's the middle of the night. I don't even know. What time is it over there? And how many time zones do you have? You must have like a whole bunch of time, like, right? You gotta have like what, 5? I don't know. I'm just speculating. This is the fun part where I just make guesses about time zones, countries I've never looked at. 11 p.m. I love it. I love how you drive. Do you stay up late, or are you up for this? It would be amazing if you just were up. It would be amazing if you were staying up for this. Okay, I'm not gonna waste any time looking for that. So here's what we're seeing. Okay. So we're actually doing quite a bit of writes. So this is still a pretty write heavy workload. Oh, nice. I love it. So what we're seeing here is it looks like this is 90%, 99% reads, no, it's 99% writes. Did I do that on purpose? Was that really what I wanted to do? Let's take a flame graph because that's what I do. I love taking flame graphs. Okay, so we're gonna okay, so C flame Cassandra 0. We're actually going to do 2 flame graphs. So we're going to do this one. This is going to run for a minute. And, we're going to keep pushing more load on here. Yeah, see, we still have hardly any data. So it's probably a good thing that we're just going to keep writing. So this test is a very, very basic test. 1 gig of data. These queries are not too intense. We are seeing kind of a big variation, big variance in latency. Like up here, when it was only doing 50, we were seeing it at 40, 24, and then it spikes up here to 200. This is usually indicative of GC pauses. So what I really need to do is get my GC. What I really need to do is get the Axon Ops agent set up for 5.0 because they have all the dashboards for this setup, and through our partnership, they're letting, one, they actually let anybody use 6 nodes for free. But I also have partnered with them for my training program, and they're providing their dashboards. They're providing like tooling. It's actually going to be really, really cool, and they do a great job. So let's just see what this looks like. Oops. This looks like the later one. Boom. Okay. We're going here. Caleb, if you're curious about taking a look at any of these, I'm happy to share it since I know that you want some performance data. And then, I mentioned I was going to do a separate version. So here's the cool thing. You can also pass arguments to this. So I can do like -- reverse, and it'll automatically grab it. Now, the reason why I like this so much is because I've done a whole bunch of tests in the past, and I've actually forgotten to pull down the data, and I've torn down the cluster. So the thing that's really nice about this is when I run the cflame command here, I actually get a local, like a local copy of it. I don't have to worry about what happened to it. And the other cool thing about this is that since everything is in one directory, like it actually treats, you can see here I'm in clusters streaming March 27th. So I've created a cluster specifically for today for this, and everything about it is stored here. So the Cassandra YAML, that patch file that I showed you earlier, that's here. The JMX configuration, that's here too. Like everything is sitting in this one directory. So now all the artifacts are sitting here too. So whenever you run a flame graph, you can get it here. I'm probably going to make some other utilities for running things like there's a really nice tool called XFS Slower. Right? XFS Slower is really great. And I say XFS just because I format everything as XFS. Artifacts, Sandra, oops. Look at that. And now it's already here, right? Boom. So now I have a reverse flame graph. So if you're curious about where the time is spent and you want to like understand what's going on with your system calls, you can. Now, the really interesting thing here is that we spend a ton of time doing like just in this SEP worker parking. This is taking 21% of the CPU. This is not my favorite thing. There's a lot going on here, and you can see that this system is actually like not, let's see. So we're not like doing an absolute ton on the CPU side of things, which is a little weird that we would have. Actually, I kind of want to know why I'm not getting better performance out of this. Oh, but then the latency numbers are down here. So this is actually, this is in order to satisfy the latency requirements that I told it. It's reduced the throughput so much because of the GC pauses. So this is, I'm going to stop this test. I'm going to get rid of this. The GC variance, I'm not interested in looking at the GC side of things right now. And I'm going to get rid of this so I don't populate. I'm going to save this original query though. And I'm, of course, once again, not showing the right screen. And this is really annoying. Boom, there we go, back here. So I'm just going to save this. I'm going to save this because I want this. Because someone, don't know who, but someone might want to reproduce these tests. Okay. So now we're just going to change this, and I'm going to set this up to run at, I'm going to have it do 1,000 queries per second, but this time it's actually going to be mostly reads. So it's going to be 90% reads. So let's just see what this looks like. So the other thing that we can do here that's really useful, and this is going to be kind of critical to judge performance. So let's do another one. So here we have back to the streaming environments. Should probably have it name. I should probably let it myself. I need the ability to name the graph. That's what I need. The timestamp isn't going to do it. All right. Got to add a name. Probably also add titles and things like that make it fun. Oh, I guess I could just title it. I'm pretty sure. Yeah, okay. All right. Let's see how that goes. So here, let's see what happens if I do cflame Cassandra 0. Oops. Cassandra 0, title, read heavy. And then I forgot what I did here. What was this? Global false, 1K. So let's just call this read heavy 1K. I don't know if this is going to work because stuff fails all the time. That's just life. Yeah, see, didn't like that. Didn't like my I'll do it on the box. I'll fix that later. So I can do the same thing here. I can do flame graph, title, read heavy 1K. No? Oh my God, come on. Let's see. So it must be because of the way that the quoting works here. I'm not sure how to make it preserve the quoting, to be honest. Maybe if I do that. No. Okay. Well, whatever. I'll just do it manually. Oops. So I think that, yeah, see, there we go. So ASProf, we're going to save this in Mount Cassandra artifacts, read heavy 1K. I was going to do a title on that. The whole reason I'm doing this. And then, let's see, come back to this. So, okay, so we're actually getting decent latency here. This is 2 milliseconds of latency, 2 milliseconds of latency, 800 requests per second. So this is, let's make sure that this is hitting SAI. Now there's only 5 million records here. So this is doing a search within a partition. So I'm actually not surprised that this latency is pretty low. This should be low. There aren't that many rows. I could redo this test with like a million rows per partition and just see what happens, but that's not really the point of today. Today is just kicking the tires, seeing what's up. This is not a deep dive. We'll see what happens if we do this. Whoops. Pass the Cassandra PID. There we go. So I'm going to do another one after this. The next one's going to be for allocations. I am going to take a look at these flame graphs in a little bit. But what I'm going to do now is let this run for a sec. So this latency is pretty good. I'm actually going to crank this. We can do more than 1,000, clearly. Let's try 5,000. And then this is going to give us some weird data. So I'm going to let this ramp up. Is there a limit on these queries? Good question. I don't think so. However, it's 5 million records spread across 100,000 partitions. So everything would be fairly small. Let's see. There is no limit. Easy cast stress. So I could actually add in limit here. I would need to do a little bit of work though. That's not going to happen anytime soon. Query performance search correlates the number of matches. Yeah. I'm fully expecting that performance is going to degrade with the number of matches and the number of partitions that it has to search. So this is only doing let's see. Do we have a way of getting everything? Oh, I know what we can do. I think we actually have a virtual table. Maybe? I thought we had a virtual table for prepared statements. We have virtual tables for all sorts of stuff. How do we not have? Sad face. We have a few for running queries. So we have a prepared statements count. Yeah, I am. Queries, cool. Thanks, Caleb. Why do you lie? Well, that's garbage. File a bug. All right, make a note. File a bug, me. file bug. Okay. Anything else that we can do on here? I haven't looked at this in a while. No. I already did that one. Okay. Well, there's some SAI virtual tables as well. Okay. So we've got some virtual tables here. Can I do this? Forget if this works. I forgot how to do the. I want my results in long form. Expand. And then I can do that. Whoops. Boom. Cool. Okay, so this makes it a little bit easier to show while streaming here. So we've got key space name, index name. So we actually have the SS table name that this is associated with, the cell count, column name, end token, format version, the different row ID, min and max, start token. Okay, this is cool. Okay. What else do we have in here? Let's try this one. I think I want segments now. And the reason why I'm doing this, by the way, is because of this. So, pretty cool. We can see some data. I wish that this worked. I'm not sure why it. Where was it? Queries. It's really unfortunate that this doesn't work. What else do we have? Okay. All right, so we've got our three things for SAI. Do we have any no tool commands for SAI? Oops. Anything that can help us understand this better. And by the way, like I'm just going to go back and point this out. We've got 2 milliseconds of latency, P99. We're doing 500 writes a second and 4,500 reads a second. So I'm actually going to increase this because we're not even remotely at this thing's limit. Like we've got 8 CPUs here. MP stat is telling us that we're mostly idle. So let's just go ahead and let this thing let's let it loose. Let's let it loose. Let's go 20,000 requests a second. Hey. Most things you'd want to do with SAI via node tool would be things like rebuilding the index, which fell under existing commands. But you can rebuild the index with What does it do when it rebuilds the index? It just rebuilds on every SS table? It's interesting. Okay, so there's nothing in here. Incrementally per SS table. Okay. All right. Okay. Forgot that we had Swiss Java knife in here. Okay, so this is still warming up. So one of the I had to add in a warm up phase because otherwise things just don't do well, and that specifically is because of the Google rate limiter. The Google Guava rate limiter does not behave in it behaves a little counterintuitively. If you set it at like 1,000 queries per second, it will just like blast you with to start. And then the other thing is that this uses an internal queue scheduler. So I want the whole thing to get warmed up before it starts outputting like crazy metrics. Because the first like few thousand queries are actually going to have terrible times. So this is doing just fine. So this is still not warmed up all the way to its max, but you know it's pretty nice to see this. But again, this is really not going to be super indicative of the main issue here. So let's just go ahead and let's get yet another flame graph. So I think next I need to figure out how to improve the naming. Do we have a way to validate that we're getting results? You mean that there are any? Put this up. You mean that there's any results at all coming back? This isn't validating any correctness. So it's possible if SAI is totally broken. But what we could do would be to look at the network. We could look at network, or we could look at I think we have some metrics recently. Actually, I think I may have added this about the about the response size. I think I actually ported that over from another fork. Just take a quick look. And of course, doesn't show you the stuff you want to see because it's the most annoying thing. Still seeing a lot of time spent here. 25% of time is spent parking threads. Oh, that's really annoying. I really hate that. God, it really bothers me a lot. And then what do we got over here? We're still mostly idle. Let's just jump over to jump over to the stress node, and we're gonna run TCP top. So let's just see what we're getting back bandwidth wise. Do we have a? Yeah, we should probably add in some sort of extended metrics. Let's see. Again, I'm showing you the wrong screen. I'm gonna freak out if I can't get. Okay, so this is a. What I was trying to show was this tool right here, TCP top. TCP top is pretty cool. There are metrics for SAI internally, but they're not exposed. Maybe a Jira. How do we not have metrics just for the number of what we need are metrics around rows returned. Whoops, I accidentally aborted my stress job. Okay, let's just, you know what, 50,000 a second. I don't care. We're going hard. In fact, we're not just going to do 50,000 a second. We're actually going to change this read rate. This is going to be 50% reads. If this is giving us the same response times, there's probably something going on here. But I don't know. I think it might be okay. Because I have run this before. And now we're ramping this up. So let's just jump back on the node. One of the downsides. So in testing 5.0, I had been relying on some of the Axon Ops stuff, which works with 4. It actually works great with 4. We could run a few manually. So yeah, I can use SJK, which is now in Node Tool. I could use SJK to pull out some of the metrics that I want. Let's go ahead and do that. This, by the way, is okay. So this is starting to, we're actually starting to see some pressure on here. Before I do that, I'm just going to go ahead and take another flame graph, because this, now that we're seeing latency in the hundreds of milliseconds, client. Okay, so maybe client request size rose red. Do we have a virtual table around that, Caleb? And all this stuff needs to be in virtual. Like, all this stuff needs to get into virtual tables. It's killing me that it's not. We have this sidecar project that we started years ago. There's almost no work that's gone into it. And the only way that it's going to make sense is long term is if every single metric is available in virtual tables. And we have a admin only connection that can run locally that never shuts down. That's the only way that the sidecar is ever going to make sense as a metrics system. Come for the load tests. Stay for the ramblings. Okay, wait. We said I wasn't going to do that. We're going to do node tool SJK and see what happens here. So, okay, so these numbers are actually not bad. I think what I want is MX dump. How big are the indices compared to the data files? Let's check it out. So here we have a 206 meg data file. And then we have all this SAI stuff. So this is 300K, 17 megs. Why is there a 0 byte file here? This is weird. 337 partition key offset blocks, 6.2K, 600, it's called 700K, 100K, 2 megs, 30 megs. And then 6 megs, 24 bytes, 364 bytes, 18 megs, 24, 26. And then down here, posting lists. What are posting lists? Then we have terms, data. So it'd probably be good to figure out what each of these do. Just going to grab this. And help. Whoa, didn't mean to do that. Okay. Okay, now this, oh, geez, come on. Let's just drop this. So I'm basically just, so node tool SJK. I think it was added in either 4.0 or 4.1. MX dump, as you can see here, maybe, is it literally just outputs everything. It is actually fairly heavyweight, unfortunately. Anything that you do over JMX where you're extracting a lot of metrics is unfortunately very, very heavyweight. Postings and terms are actually very large there. Okay, postings and terms are actually very large there. Postings are compressed lists of numeric pointers to rows. They represent matches. Interesting. I'm gonna have to go and I'm gonna have to look into the format. Looks like another thing to learn. Terms are also larger phrases, and the try may not compress them well. Because I have big blocks in there. Are there? So I'm curious what this means here. So because I created just a custom index and I didn't specify any options, is it exact? Is it exact search? That would explain why the results are so fast. So what I assume then is happening is that this index, because it's on the text field, but it's not tokenized, then exact matches on those phrases. Okay, so that explains why the searches were so fast. So my SAI load test or my SAI schema configuration needs to tokenize the terms. So question is, how do I do that? The numeric index looked much smaller, which we would expect. Okay, so if I'm trying to figure out, can I make a change to the existing index, or do I have to create a new one? If I create a new one on the same term, on the same field, the query looks like this. Hold on. Let's jump in here. This is a kind of a weird. This is weird. So here's my SAI test, and this isn't really like, this clearly needs a little bit of improvement. So here's our prepared statement where we're doing our inserts. So I guess the only thing that we're really searching now is on, it's probably almost returning no results, which is why we saw a TCP top. It's a real shame that we don't have that as a node, either a node tool command or a or virtual table. That would have made debugging this a lot easier. So when we do this, if I create a second index, so the searching is just equality. When I search an SAI index, let's take a look at how that works, because that's going to be important here. What is this? If we tokenize the source text to single words, you'll probably get better compression and larger posting lists. Okay, here's my question. Because longer logically, smaller physically. So if Caleb, I kind of want you to just join the stream. If I create another index, can I create another SAI index on the same field, or am I just limited to one? And if I do that, because there's no notion of, like, because the search is just equality, does it like, how does it select the right index to use? I mean, I guess the first question is, can we even do that? Here's what I'm going to do. I'm going to bring this up. I'm going to share my screen here with my browser. So let's just go ahead and take a look here. Oops. Okay. I just dropped the existing index. Even if you add a second one, I guess the question is, how does it know? Can I specify the index name? I don't think we have any index hinting. The issue I have is that what I'm trying to say is that how do I join? Oh man, I can hold on. Let me see if I can get you on here, man. Can I invite you? Oh man, this is great. I'm so excited. Caleb, check out ASF Slack. Okay. You can specify the name when you create, but not a query time. Okay, so here's my issue. If I have two indexes and they deliver separate results, like they deliver totally different results, then it seems to me that it's a little weird that I do an equality search and then it's arbitrary which one I get back. Like non-deterministic index like search results are kind of crazy. So I think we actually, to me, that seems like a problem. I don't know. it seems like something that, so let's say that you're me, right? Let's say you're me and you have created an index and you made the wrong one. And you made the wrong index. How do you fix that? I don't know. Oh man, it's already 11. It's already 11:10. Shit. Okay. Where does the time go? Right. Right. Which is why I think we need an index hint or some way to make this deterministic. I guess I just see this as like a foot gun. If somebody creates an index, it's not working. Like the exact situation I'm in right now, where I'm like, I made the wrong index. Like, what do I do? And by the way, this is how I figure out new stuff. I literally just bang my head against the wall, read code, and ask smarter people. Oh, I love it. All right. Where are the this page doesn't have any examples. How do we not have, oh God, why do we do this? Put that on my to-do list. Add examples. We need examples. Filing that Jira. I've got like a whole bunch of Jiras coming out of this, which is kind of cool. Quick start. Yeah, I mean quick start. Okay. So when is this normalize? Interesting. We have normalize here twice, but we don't actually say what normalize is. Yeah. You can't tokenize on the index yet. It's Unicode normalization. Oh, okay. So wait, I'm confused here. So do I actually get any? Can I tokenize my search terms? By the way, Caleb, I sent you a link to join. I don't know if you're able to do it. If you want to hop on for chat with me on the stream. So yeah, I'm still a little. I'm still confused here. Oh, okay. So then I should just go ahead and change my search to be on the integer field. So instead of this, let's just stop doing that. That's here, let me switch this up. I know what I'm going to do. I'm going to just do this. This is the easiest thing that I can do to allow me to continue. So here, let's just take a look at the SAI test. So I hope I'm showing the right thing. One sec. So the SAI test here See this? Dynamic workload parameters. These are pretty fun. So if I do, so I know that I've got this value in here. And I know that these two were both created. These indexes were both created. So I can do search fields. Workload dot search fields equals value int. And then let's also just back this up because this is going to get just absolutely destroyed, probably. We'll do 1,000 queries a second. Yeah. Hold on, I'm going to need to put headphones on, or else I'm going to get a ton of reverb. How's it going, man?
Going all right.
Good to see you, buddy. I like this. Look at this. I'm getting guests on now.
I should have just joined from the beginning.
Yeah, I don't know why. I don't know why we were trying to do the heavily. I think it's like a 20-second delay or something on the chat.
Oh yeah, I didn't know if it was like a moderated where you had to put it in, or it actually took that long.
No. I'm. People can. I suppose it could be abused if anyone wanted to take advantage of my non-moderated channel. So what I'm trying to figure out here, you already know, is what I can and can't do, what this does and doesn't support. So it sounds like there's no. Is it possible for me to put in a block of text and do like full text, like tokenized search?
So in the phase 3 epic in Jira, there's a bunch of stuff describing this and where we'll go eventually with that in terms of Lucene support for tokenization. But right now, what you have is, so there's no tokenization at indexing time or query time, but you have a few basic filtering options. So you have the option to do like Unicode normalization and case insensitivity if that's convenient, both of which would be reflected at query time as well. They'd be congruent to the query time.
Okay.
So so that's what you can do now. If you have a case, so when you look at the composition of those two indexes on disk, my guess is that the numeric one is reasonably sized compared to the backing data. And then I think what you end up with there with those phrases is that the phrases are essentially unique, right? And so because the phrases are essentially unique, your postings lists compress very poorly. And so that's why, so when you look on disk, you had the postings file and the terms file, and they were both huge. They were both huge, right? So the postings, because they're like as many single postings lists as there are terms, and then the terms are longer phrases, and I'm guessing didn't compress super well in the try on disk. So yeah, I don't know. I'd probably, with this kind of test, I'd probably just tokenize at the client side, and then you can do a bunch of single word searches.
So when you say tokenize on the client side, you are saying that I would insert one row per token into a partition?
Pretty much. Not per partition, but like per row.
Well, let's suppose I had a nursery rhyme. Mary had a little lamb.
Yeah.
And Mary had a little lamb. Okay, 5 words. Would you then are you then saying if I want to make that searchable as a full text field, or searchable as a treated as a full text document, I would essentially create a partition for Mary had a little lamb, and then do my own tokenization and insert my like frequencies and stuff like that as metadata along with the like the term, the frequency, the weights, anything that I want associated with that individual term, and then do the search and then get those back and apply the weights to.
I mean, right now, just there's like full text search is just not something that you'd be able to do at all right now.
Okay. So
Like the
no,
whole
let's just
TFI,
take it off the table.
like yeah, like the TF-IDF thing, or like the closest you could do is probably to use like the vector search stuff,
Yeah.
which would be another way to do relevance. But right now, relevance is pretty much just not even on the table,
Right.
outside of potentially the vector search stuff. So yeah.
Okay. So we're taking full text off the table. I'm going to bring up my terminal here so we can look at what I'm doing. I just created this. It's a little sloppy. Boom. Look at that. We now have,
Nice, I can see.
you and I can now discuss what we're seeing here. So this is now, I don't know if you saw the test that I started, but this is running search fields value int. So value int.
Is this equality queries on the numerics?
Yeah.
Cool. So it ranges as well, but equalities is a good place to start.
Yeah, I'm looking. I'm trying to remember which. So int is between. There's 10,000 total values. So it's a random. It's a rand between 0 and 10,000. So there should be results actually coming back for this. So this makes a little bit more sense. Based on this workload makes more sense, at least based on what you're saying. Oops. Okay, and let's just see what it's doing. Let's see. So this is a pretty cool utility. I don't know if you've used this, file top. It can essentially give you kind of like a top style, like just like TCP top. And, we can get helpful, well, if it ever starts. This is another BPF thing, eBPF. So here we've got like, so is it ever actually hitting? Doesn't look like it's ever hitting the indexes. That's a little weird. Let's do this. Let's do this. Let's take a look, and what I'm going to do is so this is going to record all operations, and it had SAI in it, right? What's
the
it called?
file names?
Is it in caps?
Oh, it might be.
Yeah.
Yep.
Okay, there we go. Okay, so I'll just do this. Grip. And then, we're just going to save this because.
Yeah, you're gonna have metadata on the SS table indexes and the segments of those SS table indexes that have like min and max terms and stuff like that. So definitely, if you are outside, and they also know about the range of tokens that are contained there. So if you're outside of that, you can have situations where those SS tables aren't searched at all. That could be one way you don't actually hit the terms and postings.
What I'm seeing here is I'm not getting any reads to the SAI directory.
Does this, is the whole index cached?
Well, this is a file system monitoring thing. So as long as it's hitting the file system, we should see it.
If you just submit a SQL query against a value we know is there.
Yeah, that's a good call. All right, let's try that.
Does it see it?
Oops. Okay. Probably should have started with this, just executing queries instead of trying to run a stress thing. Oh, whatever. I like to do things the hard way.
Yeah, we've got to find a way to build some validation to easy cast stress.
Oops. Do validation on the okay, this should hit SAI, right?
Yep. The only way that wouldn't hit disk is if that's in the mem table.
Okay, well, let's address that issue. I mean, I'm like, or I've done something totally wrong here. But this is I've done this many times before, so I'm fairly certain I didn't break that. Oh, John, I'm sorry today. I'm mostly distracted because of work. Oh, Sarma, you are missing a treat, buddy. SAI day, day one. This is actually probably going to be like a multi-week thing because I clearly don't know enough about it yet. Caleb, would you be down to join again if we're going to talk SAI so I can get some real-time fact-checking on my my nonsense?
I would love to.
Okay. Compaction. Okay, so this does prove that at least the indexes are being
compacted.
I should have I'm assuming then that we'd see it in the read stage thread.
Yeah, right. We'd want to see something from a read stage thread.
Yeah, so let's just do that. Right?
Yeah, as long as that's a prefix.
How do I not ever have anything in the read stage? It just seems like it's going to be wrong. And it didn't show up before. I don't know.
So the query works after we flush, yeah.
Yeah, so we flush.
If that query works after flush, after it's guaranteed to have been flushed from the mem table, either it's coming from SAIs on disk structures or it's magic.
Okay.
Yeah, tracing. Reasonable tracing support does exist.
Okay. So we've got
if you go all the way down the bottom, So you have indexes, access table indexes, 5 SS table indexes, and 5 segments. Each of the SS table indexes is probably small, so a single segment, and it post filtered one row in one partition. So
that makes
you
that.
don't have you don't have deletes, so you'd expect the number of matches and post filters to be the same there.
Here, let's do this. Let's just make sure that this should give us. Yep. Okay, there we are. So we do see what's happening in our read stages. We do see that it's going here. Oh, are they mapped?
The index files are.
That's why.
Yeah,
this doesn't.
It's sort of like how we have like the nmap index only setting for the rest of the things, and the data files aren't nmapped, but like the primary index is, secondary indexes for the most part here are.
Okay.
So I guess all you're seeing there is the data file accesses for the post filtering read.
Right.
Which is good. It means it is doing post filtering reads, and if it's doing post filtering reads, it is likely returning results, since you only have it's a simple query and there are no deletes.
Okay, so I'm gonna need.
You might have some updates.
So if I were to,
that's it.
You know what? I bet. Okay, so the files are mapped, which means we're not actually hitting the file system. We're accessing it basically as memory. So if I were to flush, if I flush page cache, does that purge mmap files? Let's find out.
That's a good question.
Yeah, I don't even know. Okay, now so what we'll do is God, I always forget which one this is. No. I always have to look it up. It's like the thing that's probably most copied and pasted in my life is, oh yeah, it was proxys VM drop caches. I should probably put this on like flashcards so I don't forget. Okay, and then no. Okay, so this doesn't impact that, which I guess makes sense, sort of.
How do we do that?
Oops. Yeah, I think I need to look into the mmap type like tooling, because I don't really know. I don't really know the.
Yeah, I can't find it either.
Yeah, I mean, what I really want is like observability for mmap files, which I don't. I have never. I guess I could use eBPF to trace specific kernel functions. So maybe what I need to do is either I need to get the right either K probes to attach to, I guess. No, oh no, okay. The reason why it's not going to work is because it maps the kernel address space to a user address space. So when it does a mmap operation, I don't believe there's a system call. There might not be a system call involved, but I'm not sure. And if that's the case, though, then we should see it. We would see it with a flame graph. So let's go back to my old favorite. So this is running here.
In the flame graph, I can definitely help you identify where that's happening.
All right, let's do that then.
Most likely you're going to be in classes with a suffix reader, like postings list reader or
Okay.
a few other ones.
So what I'm going to do is I'm going to get, fill that, there's nothing there. I'm going to get two graphs then. I'm going to get a regular one and I'm going to get a reverse one. And then I'm putting on my to-do list to make it.
We should try some numeric range queries if we have time.
Yeah, we can. So let's see what's. I built the SAI workload when I was first trying to look at it. So there's a good chance that I didn't do. But oh no, I do have the ability to do comparisons. I did add that. So if I do this, whoops, yeah, that's fine. So you're boom, nice. Okay. Can we do there isn't between support, is there?
Not syntactically.
Yeah.
One of the things about the numeric ranges generally is that the size of your range should not really impact. I mean, assuming like a limit, if there is a limit, if you have at a constant limit, let's put it that way, the size of your range should not really affect query read latency.
Okay.
Because the way that the tree is structured, there are as your query, as your range gets larger and covers more of the term space, the number of postings lists that you have to merge out of that to get your final result is sort of bounded by a constant number of postings lists.
Okay.
Because there are internal, like the internal nodes of the tree, so to speak, in the balanced tree that has the numeric values. There are like summary postings lists or auxiliary postings lists, if you will. And
so wait, refresh my memory. The posting list again is the list. It's the rows that match the terms.
Yeah, the postings list is the concept that is probably the most familiar for people with a background in Lucene. And essentially, it's just a sequence of increasing numeric values. And so what you have there is a lot of opportunities to compress. So you can do windowing there, organize that into blocks, do delta encoding. So there's a lot of opportunities it's really easy to make that pretty small. And the actual values there logically are row IDs. And those correspond to like the ordinal positions, the positions of those rows inside the SS table that those are attached to. And that's really, I mean, at the end of the day, that's the concept that ties together all of SAI's local storage format concepts And what allows it to compress much better than, say, like SASI did, is that the concept of that row ID, which compresses very well and can be stored in like per column and in a bunch of different places,
Mhm.
and then have all the stuff that's actually larger to store, the stuff that's bigger,
Mhm.
stored in something that's just attached to the SS table and is used by all the column indexes. If
Okay.
that makes sense.
Yeah, I'm gonna have to think about it a little bit more when I'm not juggling the this stuff as well. I just discovered that I have another bug in my my thing, that it's not using the inequality, and it's I'm actually like looking directly at the code where it is. So not using. All right. So to improve this SAI workload, there's a few things that it sounds like I should do here. One, the text should probably not be as it seems like maybe decreasing changing the cardinality of the terms. There's essentially like there's no like maybe making it so that it's let's see. I guess just if I were to do a random string of characters and just limit the length of the characters, then you're kind of limited to like it's just the length, right? So I forget if I allow for capitalization and things like that, but
Yeah, more or less any. Let's say you do the case insensitive option, and then really like any natural, like any English text, pretty much. If you even if you leave like stop words in and stuff like that, we don't care.
Okay. So
You
I'll then change it to like I'll change it to like 1 or 2 words instead of 5 to 10.
Yeah, I mean you can even just I just word tokenize. Just like tokenize on Word, and then you'll get you should get a ton of compression in the try, and you'll get a little bit longer postings list. It'll be easier to find some values that have more matches.
Yeah.
That's probably the way I go. It's just a matter of like how you build the model, I guess, on the like for queries.
Okay.
Since it's not coming from like it's not generative in that sense.
Mm-hmm.
You just have to build a little bit of a model, or maybe some sort of like sample, like trailing sample of the words that you've indexed, so that you have something to query, if that makes sense.
Okay. Okay.
If you want to actually find a match. But yeah, that you could sample at whatever frequency you want, have a certain bounded number of things to choose from, I guess.
Yeah.
Or you could just go generative all the way and just have some just take random strings, of a certain length and go that direction. But
the way that it works right now is that there's a like each workload, and you can override this at runtime. There's like a field generator. So like a text field, you can say that you want it to be random, but you can also say that you want it to be words from a book. So it is a pre-built like Creative Commons book that like I think it was like Moby Dick.
There's a lot of nice things about that, because it gives you like a more organic distribution of words.
Exactly. Yeah. So what I'm probably going to do is have it clean up. Like I'll do some normalization of it. I'll remove whatever other like I'll just turn it into like lowercase and spaces. And
Yeah,
then
and you don't even have to turn it. You don't even have to turn it into lowercase if you don't want to. If you just enable the case insensitivity thing on the index itself.
Yeah.
If you
So
want to test it out.
the I think the main issue right now is that it's searching within a partition. There's only a handful of values, right? And so the odds of it actually matching on one of the arbitrary selections in the book, because it's literally just saying like pick a point in the book and give me the next whatever words. So if it didn't match that exact thing, then it's not going to help. So this is where it would have actually helped if I had like preloaded it with 100 million records, or I could run it. I'm actually going to start this. So this should work. Then at least it should work a little bit better because we do have a few million records in here. So I'm just going to get rid of this in the search fields, all this stuff. And I'm going to do workload dot global equals true. So this will actually be the last thing that I'm messing with. But now we're actually doing a full search over the whole data set. So this will probably be a little bit less performant.
How many nodes again?
It's only 3. 3 nodes and 3 nodes, 8 cores, and 62 gigs of RAM.
Is that RF3?
I think this is like an R5 instance.
No,
I forget how to. Oh yeah. There's a. I should probably add the AWS utilities on here. Make it easier for me to grab stuff, but
yeah, if it's RF3, it's at least still only going to 1 node.
Mm-hmm.
And then, I mean, if the SS table count is it STCS?
Yeah,
probably still have a reasonably low SS table count.
So there's not going to be. Yeah,
there's
not going to be a lot at all.
I'm gonna guess it's not going to be super different.
But it is hitting. But it is potentially hitting the whole data set rather than just the partition.
We don't care though. I mean, so the thing is that whether the thing about restricting to a single partition, it's not so much that is somehow faster when you're searching in a single SS table. It's that restricting by a partition, especially if you like use LCS or UCS configured like LCS, just hits fewer SS tables.
Right.
When you do a query that's partition restricted versus not partition restricted, and say they're both over 5 SS tables, and one's a global query and one's a partition restricted query, the actual query on the terms index is the same. It's the exact same terms index for all 5 SS tables, and it returns the exact same postings list. The only thing that changes is that when you have the partition restricted query, it's going to skip efficiently in that postings list to where that partition is in the postings list, or more correctly and specifically the row ID of the first row in that partition in that postings list.
Yep.
And that's how pagination works. It's how pagination is supported, and it's also how so it is a little more efficient,
Yeah.
But the big thing is that combined with your selection of compaction strategy, just finds fewer SS tables.
Okay.
Because we obviously collect the tables that have a min-max term that don't match your query term, or that don't match your token range, which is implied by the partition key.
Have you looked at UCS and how UCS and SAI impact each other?
Not a ton. Where it would, if it replicates, if it can be made to replicate the read side characteristics of LCS, it should just work pretty well for partition restricted reads. For global queries, for global reads, which is the non-partition restricted case, where it could help potentially is if it was better about minimizing the number of active SS tables. But I mean, STCS does that already, I guess. So I don't know.
Well, so what I'm hearing is if you could get some of the characteristics of STCS, which is fewer SS tables, but also you get the advantages of LCS where it's actually bucketing. Like UCS doesn't just grow to like infinite size SS tables. There's actually restrictions in there to make it work better with larger data sets. So it seems to me that if you use STCS or if you use UCS with, I guess it'd be like T4, I suppose would be the setting, the tiering. I wish it was S4, but T4 tiering, then you'll get your data to be partitioned better. It does kind of cap the maximum size of the SS tables, and you can get kind of some of those benefits without necessarily having like a trillion SS tables.
Yeah, I mean, if there any partitioning on a token basis at all that is like in addition to what STCS does, would like move the needle. Like if it didn't also involve a proliferation of SS tables, would move the needle toward it being generally useful for all cases, partition and partition restricted. If that makes sense.
I think so.
Yeah.
So here's what I'm going to do. This is going to be the last thing I'm going to fire up. 25,000 requests a second against the 3-node cluster. 50% reads, global queries. Now, I recognize that to really test this, I'm going to need a much larger data set. But this is kind of just to get a feel for what happens with a small one.
So we got ranges working here.
This is not ranges. This is actually the text one. Do you want me to try ranges? Oh no, it won't do ranges. My code's broken.
Yeah,
I gotta fix that. This, yeah. So this, you can see this preparing workloads with global true, select where value text equals, and then it's equality. So I don't think that there are millions of words in the book that I had at index. Oh, but it could still. Okay, let's just do it on the numeric field. It's not going to do a great job. I've got too many issues with the text field. All right, so that SAI test, we're going to have to do some work on that. But workload dot, and then I think it's search fields.
One of the common things we did on the text side for testing, I mean, we just did libraries of like first and last names. I mean, we did things like that.
Yeah.
Eventually, we're also going to need like support to make that super useful. But yeah,
I have that. I have some additional field generators in here. So not a lot though.
those also end up having to probably add more filtering, like have that as like an AND query to get selective enough to be useful.
Yeah.
Given the the cardinality of like first names, for instance. But we can't.
I may end up needing to eventually just do something where it like generates like a matrix of like potential queries and then like does a load test with like each of them. Although I guess that's kind of veering off of what the point of this tool is. Okay. This makes a lot more sense. These numbers are more or less in line with what I'm expecting. So we're seeing a shitload of errors over here. So we're not going to go for the full 25K. We're just going to bring this down to like.
This is the global and numeric one.
Yeah, so it's that. So here I'll actually just drop this in the.
Okay, that's it.
Yes, look at that. We have a banner now. So we have our. So this is the test that I'm running now. but it's only going to do 100 queries a second, which seems to be probably too much, to be honest, because it's not handling this. It may do better if it's like 50. I'm glad I finally broke it. I made a big promise that I would break. Oh God. All right. I definitely broke it. I may have to rolling
Really break
restart
it.
this thing. Actually, let's see what it's doing.
How many matches do you think that's getting?
Oh, I'm sure it's a ton. I'm sure it's a lot.
There's a certain point where, and this is actually Jira I filed yesterday, but there's a certain point where just the overhead of the huge number of local reads you do, just every match you have to read from the normal read path, but those aren't even batched in a names filter to do multiple clusters at once. So I gotta fix
that. we're completely.
I haven't seen an HTOP view like that since the last time I was on call when there was a leap second.
Yeah, it's pretty rough. So we've got. You know what I'm curious about? I'm curious about if our time is if we're in lots of GC or if we are actually if it's just going absolutely nuts. So we're gonna find out.
I really want to know. So if we had a CPU flame graph here, well, CPU or an allocation flame graph, really, but
we
CPU
do
for during those reads to see if we're just creating so many single partition read commands and just spinning our wheels doing all of the reading and post filtering of those rows.
Yeah. Well, we have one here. So this is this name right here. I'm actually gonna hold on. A stream. Whoops. So let's just call this Flame CPU overloaded. Because you want this, right?
I would definitely look at it.
Okay, let me bring this up. So glad you joined, man. It's nice to.
Yeah, I think
nice to get into this with someone that actually knows what's going on.
I definitely think I am gonna get something to eat soon, but
oh yeah, I'm wrapping this up. I'm on we're 2 hours in, so I'm just gonna switch my screen. Okay, so our CPU profile. Oh,
row iterator. Yeah, okay, once this banner goes away, I'll be able to see this a little better, but that one in the middle there, see how you have query controller, query storage, and then below that you have result retriever, query storage, and filter.
this right here?
Yeah, see that thing?
Yep.
Yeah, that right there, that is SAI after the index has found a match, right? It was the postings list, gives it a primary key. That's it, right? So it's got that primary key, and it's taking that primary key and doing a single partition read command to look that up in the local through the normal read path.
So it does. So it does one read to the normal read path for every. In your Jira that you filed is to bulk read.
We at least need to, like within a partition, at least need to batch up the clusterings that we're reading. Like if we have 100 rows in a partition, we don't want to issue 100 single partition read commands.
So when you have, let me ask you this. This is a question about the life cycle of the SASI or the SAI.
Yeah, this right here, I will literally take this flame graph if you send it to me, and I will put it in that Jira right now.
Oh, done, dude. It's all yours. Hold on, I'm just give you this right now, man. Let's see. This is awesome. Making progress. I love this. Let's see.
Yeah, the Jira.
You wanted. Oops, wrong one.
Here,
This is called streaming March 27th. Here you go, bud. All you.
Sweet. Yeah, I mean, now what would be even more? Well, I wonder if this will also, if it will still suck in the partition restricted case or not.
Mhm. Do you know the full set of IDs that you need to look up before you? So you've got. So let me just make sure I understand this. Do you merge all the SAI results together first and then go to disk, or is the process like incrementally fetching rows as you're finding them in the index?
We lazily fetch primary keys. Well, we lazily fetch row IDs from the postings list from the underlying queries, and those are translated to primary keys. So you basically lazily fetch primary keys and then only read them when you need them. But there's no reason we shouldn't like rip off 10 or 100 at a time and issue that as one read to the normal read path. But,
Okay.
Now, if this is only a lot of reads because it's many partitions, then that that optimization obviously doesn't help a whole lot. But at least
Go ahead.
But yeah, so now if this was also partition restricted and they're just like more stuff in a partition now, and it would still do this, but
Got it. Oh man, I was hoping to avoid making a configuration driven query thing, but I'm like, I'm gonna end up supplying I guess I could always give it a prepared statement and then use the same exact configuration language that I do now for the field for the thing. There's really no difference. It's just slamming a prepared statement in and then matching up the search term. So that actually could be really useful for this, because like doing your own select every time, like, and it'd be nice if it worked per actually, yeah, that shouldn't be that hard at all. I should definitely be able to do that, because there's a thing that just says give me the prepared statement. So if I supply it, then it can use that, and if not, then it uses whatever the workload is by default. So I think that the only thing then is just making sure that the right fields match up. And this is somewhere where I get a little irritated, because I've wanted to see the CQL, parser. I've wanted to see that broken out into a separate repo and published without dependencies for years. I actually filed the JIRA for that like 8 years ago. And
I mean,
unfortunately, it's one of those things. I have a feeling nobody's going to do it, except unless I have the time, and I don't, or unless someone hires me to do it.
I mean, what's the pushback is basically what, like dev workflow?
I don't think there is any pushback. I think that
could we do it as a Git submodule?
Well, so if the reason why I use when I say sub project, I'm thinking in terms of like Gradle. Are you familiar with Gradle subprojects?
No.
Okay, I'll just present some stuff. So like here, this is a fairly like simple one. So this project, and I know that the font's a little small. I can't do much about it on this side. But essentially at your top level, you can have like subprojects. So I can have here, one of them is like manual. Okay. Yeah. So manual is a separate subproject that has its own build. It has its own dependencies. That subproject can be consumed by the main project as if it's a separate whatever. So it can be you know, it doesn't have to live elsewhere. Like I don't actually really like
It's
Git submodules. I think they're not great and really easy to
I mean,
get.
it's like with the Git submodule thing. It's I guess at this point it's just like a chord at least kind of crossed the Rubicon with it. So if it's a choice between like a Git submodule for the parser and it being not in a separate thing in perpetuity, I'd rather have a submodule. But
Mhm.
yeah,
Well, the my dream at least was that effectively, because it is coupled to the release, right? It's not like we're going to have a single CQL parser that is forward and backwards compatible where you like enter some query syntax and it's like this isn't supported until version 6. You're like, joins. What? Right? So to me it makes sense because they are so tightly coupled to just say like let's put it in the same one. And I think that like stress might be done as a submodule already, but it's done with Ant, and I don't know anything about Ant. Like I refuse to learn Ant. It's like I just don't want to learn it. I can't put it in my brain. I don't have the time or the patience.
well, it's sort of like Antler too. I
But
learned the bits of Antler that I had to for like some Accord CQL stuff, and it forced me to. You know, I didn't. Otherwise, I would not have even tried.
yeah, I don't mind like parser stuff. Like I'm actually quite I'm kind of weird in that I enjoy that sort of thing. Um,
You love your EBNF, huh?
I you know I one of my first jobs, I think my third job, um, I designed a programming language in uh, using Yek and uh, whatever it was that was in Erlang. Like Erlang had its own variant of uh, Yak and Lex, and I designed a language that ran within Beam, and it was for like leaderboards and stuff like that. Let me just see if I let me open this up for you because I think. Okay, so this is the reverse flame graph. I don't know if this is any more helpful for you. Look at all this mess. Yeah, that's probably kind of crazy. I don't know if that's helpful, but this is are you so this is essentially like kind of a this is one of those workloads that Cassandra's not great at. Like lots of reads. Just
Yeah, I mean the thing with SAI, we're going to end up in a place where if if where we are is we're here and we understand the performance of SAI queries in terms of things we already understand, like okay, just the number of post filtering reads we have to do is like our main bottleneck, then that's kind of like one big thing to attack. And so within the large partition search case, which is what I hope this is mostly used for initially,
yeah.
that's a fairly easy target, and I think we'll be able to get there. I think it's going to be that like taking the constituent operations that we have to do because of the way SAI is designed, because like we don't index tombstones or that sort of stuff. To just be able to like attack those things and make those things faster or do fewer of those things, right? And cut down on the amount of seeking we have to do for those reads, for the amount of garbage collection from creating all the crap that the 500 iterators for every one of those reads that we have to create, and that, and then on the index side, getting the basic query optimization things to make AND queries faster that like DataStax has already released in their public fork.
Yeah.
Once we do those two things, I think on the read side will be okay. On the write side, I think that the next most interesting things are going to be probably sharding the mem table index. So again, especially in the large partition search case, it's like that's an easy win on the right side because there'll be less contention on the thing that is receiving the SAI, the writes on the SAI side when that's attached to the mem table. But then on the read side, it won't even be more expensive because again, we're doing partition restricted reads.
Yeah.
So we'll hit a single shard either way. So anyway, those are the things that like we know about that are like should be easy-ish wins. Politics and like the ergonomics of the project aside. But yeah.
You want to see something interesting?
Yeah. Let's see it.
So this is no longer running. So stress isn't even running anymore. And the load on the cluster is still 100%. We have all these timeouts that we can configure, but they don't actually seem to time out.
And it's not compaction. We weren't even writing, were we? Or...
I don't think it would be compaction. I've never seen compaction take up 100% of CPU. Like it just doesn't. Not this way. And I think I only have 2 threads.
Okay.
And I also have flame graphs. So I actually got more flame graphs for us. I got an allocation flame graph. What it's doing right now, and I'll just go ahead and get another CPU one.
So SAI queries themselves should be able to time out.
Yeah. So here's what's wild. And then I've been noticing this a lot. We've got native transport requests, 30,000, right? 128 churning away.
Do we have things not timing that have been in the queue too long?
Correct.
Okay. I can talk to you offline.
This does not work correctly.
Yeah, let me talk to you maybe later this afternoon.
Okay. It's fair. Yeah, because this is
there's a thing. I'll say this. So right now there are a couple different types of rate limiting at the native protocol level that we have. One is a thing that was done before I was involved in this, where you have limits on the number of bytes in flight client. And then later I kind of expanded that so that you can actually do just like native protocol requests, just like client CQL requests in flight, where there's a limit on that. Again, that still is done above the dispatcher, and it like doesn't, it's not like you can't do things with it yet, like where you segregate by key space or even like reads and writes and all that. But there is a metric attached to it. You can see the thing that you're actually limiting, and it's pretty useful. I've used it in a few places and stopped like super out of control situations. However, there is another kind of thing we don't have yet. Are you still there, by the way?
Yeah, I'm right here. Can you hear me? Oh no, did you lose me? Uh-oh, lost you. Oh man. Well, Caleb doesn't make it back the next minute or so. I'll probably just wrap things up because we're nearing 2.5 hours. I learned a lot about SAI. This has actually been an awesome surprise being able to get Caleb in here because he knows this better than anybody, probably. Definitely want to understand what's going on here, why we would have so many requests pending when we don't have a stress load running anymore. Seems like we should be able to just drop these requests out. So I'm going to just make a note for that. All right. All right. Well, that's going to be it. Doesn't look like we'll have a return, and that's okay. We're out of time. I'm going to end up spending a little bit more time on this. I'm definitely going to make some improvements to my my tooling and the SAI load test. I'll probably file a bunch of JIRAs based on what I figured out here today. And yeah, that's it. All right. Well, thanks for joining, everyone. And I'll see you next week. I'm probably going to be pushing my time back a little bit. I'm really trying to get more of a focus on my health and trying to go to the gym in the morning. And I like to have a little bit of time, ideally, to set this up. So I might be pushing it back to 11, but it'll be scheduled. So if you look at the channel and you're subscribed to it, you should be able to see that. Or if you look on LinkedIn, you'll be able to see it. And maybe I can get Caleb back in here, or someone else that's worked on SAI for more of this, because I think this is pretty valuable. So if you like this, if this is helpful, please leave a comment. It's nice. Yeah, I'll talk to you later. All right. Bye, everyone.